This is a melty brain. It is a robot that spins at a very, very high speed, and by turning the motors on and off during that spin, you can get the robot to translate around the arena while spinning, turning the entire robot into a deadly weapon. I've been building these for a while now, but I've been building them with a twist. I have been putting spinning weapons on my melty brains, which means I have been spinning my spinning weapons just to add a whole lot of confusion and chaos to the mix. However, this has been a bit of a mixed bag of results, so today we are going back to basics. I was trying to build this robot in July for our August meet. However, I ran out of time and had to do a very rush build of something that kind of wasn't, but kind of was what I wanted to do today. I'll leave a link to that video in the description down below. So I'm finally actually getting around to the build I wanted to do then, and that starts with my CNC machine and some 6mm HDPE. This produces a ton of parts that, like all of my melty brains so far, kind of locked together with a finger and joint style. They kind of click together like big 3D jigsaw puzzle pieces. However, unlike a jigsaw puzzle, I actually want this thing to stay together long term. So we also then pilot drill a bunch of holes and then add some wood screws in to keep things together. To start with though, we're only doing the base and also attaching two little TPU skids so that we can actually put all of the rest of the robot together. And that starts with the brains of the operation, a Teensy 4 and an accelerometer taken from that old build, which didn't turn out so great. These electronics fit into a recess that I left in the base of the robot, because they need to have the actual axle bolts sit over top of them, and there needed to be clearance to get the M6 nuts to fit in there without jamming into the circuit board for the accelerometer, because that would not have done very good at all. With that board slot in, it is then just fit down with some M3 bolts and some nylock nuts to keep it in place, because that accelerometer needs to be as flat as possible to the base of the robot to get a good, accurate reading of how fast the melty brain is spinning, which is very, very important for the code to do what it needs to do to keep the robot and have it translate. Once that's in, before we pack all the electronics, it's time to attach the wheels, which are custom 60A Shaw polyurethane molded wheels over a kind of TPU hub, which has a gear printed into it. I'm running a gear drive in this particular melty brain. I'm not sure if that is going to help or hinder yet, but we will find out together. A lot of melty brains are run like this one, where they are what is called YOLO drive, and the wheel is attached directly to the motor, but I'm trying something a little bit different. Again, we'll see how we go. Those are riding on skateboard bearings on M8 shoulder bolts, with a little spacer because my actual shorter shoulder bolts didn't arrive in time, so we're just kind of buffing the actual axle out and making sure everything else sits down and fits correctly. To do the electronics pack, first we need to put in the batteries, which this time around I am using 2 batteries. Normally I would use a single 4S pack, like for this melty in front of me right here, but the new melty is so much smaller in terms of height, I can't even fit my regular 4S battery into it. So this time around I'm using 2 2S LiPo batteries wired together to give 4S power to the entire robot. This way, not only can I actually fit them into the robot, I can also spread them apart and balance them, which means that the whole robot is a little bit more balanced than this one, where there's just a big old block of battery in the middle, and if it shifts in any given direction, that moves the center of mass, which again is very important when you're spinning the entire robot very, very quickly. Once those batteries are wedged in, it is then just time to pack in the mess. Now this took a very, very long time. There is not a lot of air inside this robot at all. So ESCs are having to be tucked under my screw switch. Other things like the BEC just need to be tucked in a little corner where they'll fit. Same thing with the receiver. Everything is just a, where can I possibly fit this thing, and just jam it in there and push all the wires down so that when we click down the lid, nothing catches and nothing gets caught between the lid and the walls, which would be a bad, bad thing. It is only plastic, but CNC plastic can be kind of sharp along the edges, and soft silicon wire will definitely be cut by something like that. With those wires packed in there like that, we just press the lid on because it is time to take a quick weight measurement. This is because I sat down and bought a whole bunch of different teeth for this thing, so I have options for what I'm putting into what fights, and also options for getting the robot as close as possible to the weight limit of 1.36 kilos. And for right now, I'm going for whatever is going to put me closest to that limit. And in this case, it is two 12mm thick Hardox teeth. These are Hardox 450 teeth. They have a slot cut in them so that I could actually stack extra teeth ends kind of up and down on that block. But it also meant that there's just a little bit less weight in those than the solid versions of those teeth that I have. And that tiny little bit of weight saving pushed those teeth over the edge and let me use them in the robot and make weight. Those teeth get two little HDPE spaces, and that whole stack up is exactly the same size as the gap it needs to fit into, so some gentle persuasion is needed to get the teeth and the spaces in line and exactly where they need to be so that I can push some bolts through and clamp all that down by tightening those bolts as tight as they will possibly go. And with those teeth bolted on, that is the hardware of this robot completely done. Now, because I am using electronics and code from a previous project, we don't actually need to code anything for this. We just have a finished melty brain, which was great because when I got to this point right here, it was time to go to my next local competition. And normally I would stop the video right here, but as you can see, there is still a little bit of video left. And that is because at the event I tried to do safety and it went like this. That's not good because it turned itself off. So, as I myself said in that video, that's not good. Effectively, I tried to spin this robot up to get it past safety, because you need to spin the robot up, show movement, and then turn your controller off to prove that the robot will safely shut itself down when there is no controller inputs. I started trying to spin it up, it struggled a little bit, it finally started getting up to a little bit of speed, and then the whole robot just shut down, and everything shut down. Not only did the brain board shut down, my power light shut down, the ESCs that have their own individual lights on them all shut down. And I thought this was going to be a problem with my screw switch, so I sat there and I power cycled the robot a couple of times, just winding the screw switch out and back down again, seeing if I could maybe get some life back into the system, and none of that worked. So I knew there was a deeper problem, which is really a pain when you've got a million tiny little wood screws in the top of the robot to actually get the lid off and get back into the electronics. Before I panicked and did all of that though, I took off my little access panels that get me directly to the battery. I designed these into the robot so that I could actually pull that off and be able to charge the batteries without, again, having to disassemble the entire thing, which takes a long time. And what I found was really not good. The culprit was my 2S lipos. Well, in actual fact, the culprit was the connectors I put on my 2S lipos. I used some connectors that had wires already on them with an unknown variant of wire and an unknown shielding on that. It certainly wasn't good silicon wire, and it had melted on both of them. This is really not good. It exposed the copper on the positive and negative terminals, and I think fused the two wires together in one point, which is effectively shorting the lipo, or at least it was until the wire itself burnt out and stopped doing that, which I think was the only thing that stopped this entire robot from bursting into flames. So obviously that was very bad, and it meant that I needed to actually take the robot apart to get to the wiring inside. It also meant that there was no way I was making it through safeties before they closed in like 10 minutes at this point in time. But especially because just getting all of these screws out of the top plate takes a whole 4 minutes, and I know because I filmed it. And no, we are going to move on. We're not going to sit here and watch all of these screws come out, because that would be excruciating. Now, I did not have spare plugs at the event because I was not thinking this was going to be an issue. Thankfully, Steve had some spare plugs. He actually had some of the exact same type, but with good silicon wire on them. And with his permission, I just decided to try and give that a shot, thinking that maybe they would burn out again because I needed to upgrade to different plugs and thicker grade wire. But we both agreed it was worth a shot, and so he gave me those plugs and I wired up a new little harness to then basically do everything again. Wire everything back up, do a new set of packing on it because all the wiring was a little bit different now. And then, of course, sit there and spend 5 more minutes putting all of the screws back into the top plate. This is, of course, done while fighting other robots and doing other things at the event, so it took most of the event. This time, when it came to do some testing, I decided that I wanted to do it without the weapon teeth on, because that was just going to be a little bit safer. My thinking here was that it was going to draw less power if it's trying to spin less weight, and therefore maybe the battery connectors will survive this, and this is what happened in testing.
Well, that is drive. I'm just going to throw it straight into melty mode because if it burns itself out, it burns itself out.
So, kind of okay. It did spin up, it got up to a full speed. I managed to get a heading light set correctly on the robot. Unfortunately, the issue was translation. I tried to push the stick, the lights went kind of haywire, and the robot stayed in place. This means that the code is not working with this current hardware. I feel like it should, so either I've got a bug in the code or the gear system on the wheels is causing a kind of disconnect between when the code is telling something to happen and when it actually happens on the output of the wheel. I don't know. It's something I'm going to have to do a whole bunch of testing on to try and work out. I'm hoping it's just a bug in my code because that is a very, very easy fix, and it means that I can keep running this same system. Instead of leaving it there, I then decided to bolt the teeth back on just in case there was a beta weight rumble of any form at the end of the day. And luckily for me, there did end up being a beta weight rumble, so I threw this entire robot in, knowing full well that I wasn't really going to be able to translate around the arena and I was just going to be something of an arena hazard in the rumble.
3, 2, 1.
Yeah, I'm stuck under you. There's nothing I can do about that.
So hey, that was actually kind of cool. So yes, I cannot translate at all, but I managed to dish out a whole bunch of shots. A lot of them were fairly brutal, or at least looked fairly brutal from the outside. I also took a bunch of shots while spun up and while spun down. And yes, there are some nicks and scratches in the top of this robot. Nothing here is fatal. I might want to remake the top plate just because business time, the big robot with the wheels and the vert that you saw, took a couple of chips out of the top. But honestly, that is not a huge deal. Again, I could very quickly and easily remake this top plate and then we'd be good to go again. The bigger issue is one of the gearing system in this robot. I think at the very end there, when business time was on top of me and I was trying to eke my way out from underneath him, I actually ended up stripping gear teeth on these printed gears. The wheels themselves are just TPU hubs with a gear printed directly in the TPU, and the gear on the motor is an ABS gear. And it seems as though the ABS has somehow managed to chunk out the TPU, which I was not expecting in any way, shape, or form. So I think the next version of this, I might run the same wheels on the next version and just see if it happens again. If it does, then I'll have to change what these gears are made out of to try and make them a little less prone to just shattering against each other. But yeah, that honestly, for the fact that the code wasn't working, that was a pretty good first showing for this melty brain, and it's got me encouraged to keep working on this into the future. I'm thinking the next thing that we might do with this is I might do a live stream, open it up and just like look at everything in detail, see if there's any other damage that I missed, just see what I can see in here as we pull it all apart. And you know, it would be nice to have some company as I spend the like 5 to 10 minutes taking all of these screws out again. Because yeah, it's quite the problem. And also, yeah, there's some screws in here that got hit, so I have a feeling that some of these panels aren't going to be very easy to take out anymore. But there you go, that is it for this video. I hope you have enjoyed that one, and I will see you in the next video.